this extension is moving south, while extension here is dying out. And in this area, like here, we have this kind of explosive volcanism. Because if we had not the, if we have crustal extension, the magma makes it so easy to the surface. It doesn't have deep roots within the mantle, and we get what we call just tourist eruptions. I'm afraid this is not a tourist eruption. It has caused more disturbance with international flights than any other events since invention of aircraft. Thousands of flights in many days have been cancelled in Europe because of the fine ash high in the atmosphere. But what is happening on this geological time scale, if we look at the red here, it's so expanded this that it's not very clear, but this is the mantle plume. So the mantle plume is moving east relative to the crust or to the plate boundary. You can look at it the other way and say the plate boundary, which is this amber here, is moving west relative to the to this mantle plume. And it was way over there, Greenland, about 70 million years ago, and now it is about here. And what happens then with this mantle plume is that the crust tends to break up above this weakness, above this mantle plume. So we have the situation, mid-Atlantic ridge is here. It used to come straight through, but now it is being, the volcanic belts in Iceland are being shifted east due to the mantle plume relative to the mid-Atlantic ridge to the north and south of the country. Hvað segirðu? Sá næst mættur? Mér var sagt af Brynhild að ég hefði bara frjálsan tíma. Nei, býttu. Okay, I didn't know that this was limited, but the next guy is here. So I need to, sorry. We have two types of volcanic, of geothermal systems in Iceland. Let me just go through this very quickly. We have, within the active volcanic belts, we have volcanic systems that have high temperatures, sometimes magmatic fluids coming in a little bit. But then in older rocks, particularly on the American plate, and we have our own little microplate here in between the two volcanic belts. It's a separate plate because it has its own independent movement. And this is where we have a lot of tectonism, and so we have tectonic geothermal systems in older rocks. And the tectonic activity is really widespread. All these black dots, mostly here, on both sides of the belt here that is dying out, but also up in the north. Everywhere, in all of these areas, you can see young or modern fractures that, with which the geothermal activity is linked. The volcanic systems, many of them are associated with major volcanic centers. They are not necessarily big volcanoes, and quite a few of them have a caldera, which forms when you empty the magma chamber very rapidly, so the roof collapses into what was the magma chamber. So you have a circular feature, and this is one up in the north. We have many fossil systems, old systems, that formed in the volcanic belts in Iceland, but due to the crustal drifting, they are now in older rock outside. And what is important about these systems is they are eroded, particularly on the east coast, so you can see what their roots look like. I think I'll make this the last one. This is within the city of Reykjavik. We have this black line here, which shows how the temperature in the crust increases with depth outside the geothermal field. The red one shows how it changes with depth within the geothermal field. I hope you can see that this turning point here, which is at 1,000 meters, then above 1,000 meters depth, the temperatures in the rock within the geothermal field in Reykjavik are higher than in the surroundings outside that field. But below these depths, below 1,000 meters, the temperatures are lower. And they are really low. They start increasing here below about 2,000 meters. So this vertical bit is created by, over a long period of time, vertical movement of hot water. At 2,000 meters depth, this movement is slowing down. Permeability is decreasing. But the other thing is, we have cooled the rock here within the geothermal systems at great depths enormously. We have been mining the heat of the rock by the circulation fluid. So at great depths, down to 3,000 meters, the rock is still quite cooled by water going down, picking up heat, cooling the rock at the same time. So this is not a renewable system. And by the amount we use it today, we are enhancing this movement, circulation of groundwater by pumping out hot water. It will probably last for a few hundreds of years. So it will last longer than coal. But it depends on how intensively we exploit it, how long it lasts. So after all, it is a mine of heat. It is not a renewable resource.